part 4. Was that 4? Okay. This is getting heavy. Too old and fat for this. Now I'm going to actually start looking at the rock. Finally, we've looked at the macro structure of this rock. You know, fracture planes. This isn't a fracture plane. This was the face of the cliff, and this is where it broke off. You can tell how jagged it is, okay? We found that this ripple on here, there's striations, probably from sand particles hitting this when this was not a rock, when it was still sediment, okay? Now we look at it. What can we tell about it? Those of you who have been watching me spin this thing around for a while might notice you've got some grains in here that are pretty big, and then you have some that aren't so big, but they're still noticeable. You can still kind of tell what they are, okay? And then you see some other minor structures in here, which may or may not be relevant. You see what appears to be bedding, these lines up here. That appears to be bedding. It happens over here too, just more coarse. And in the middle, over here, this appears to be, well, laminated, but laminations are just small beds, okay? We're not going to get into whether this is very thin, medium, or thick laminated in parts. Just not going to do that. And then this seems to be pretty mixed up. It's one bed. So we got real tiny beds here, in here, and we got a bigger bed here. Okay, so we have some smaller scale primary structures. Bedding is a primary structure. What that means is it's a structure that forms when the rock is being deposited. Now, we say deposited, and when I say that, most people think of sedimentary rocks, but you can deposit any kind of rock. I can deposit an igneous batholith, okay? The magma chamber that crystallizes underground is being deposited, okay? You know, it's just means the rock as it's being formed, okay? Or being put in place, all right? That's really all deposit means. But like the bedding, this lamination, this bed, like this bedding, primary structures. We don't see any other primary structures in it. Primary structures, like the fracture plane, is not a primary structure. That did not form while this was being deposited. It did not form while this was being lithified into a rock. It did not form even when this was being borderline metamorphic, you know, a little heat and pressure. It formed when far later than that, probably within the last ice age, all right? So this is a secondary. If we can't identify if it happened second or third or fourth type of structure, we just say it's secondary structure. But we would never call a fracture face primary. It would be at least secondary, okay? Because these don't form while the rocks form. The rock has to at least be a rock for fractures to form in it. You can't fracture something that does not exist, okay? Even if it's still like an igneous rock because it hasn't solidified, you can't fracture a liquid, all right? So we look at that and we see we have some very coarse grains. And look at the shape of the grains. Are these rounded like you would expect in a stream? Okay. Are they? No, they're more jagged. They're angular. Look at them. They're very, there's a couple things that look a little rounded, but the vast majority, 90+%, are jagged. Even the smaller ones, let me see if we can zoom in without it blurring on you. In here, I don't know if you can see them very well, but they're angular too. We call that angular. This shape of most of the little tiny particles in here are angular. We don't even have any subangular ones really. We have a few, but this is mostly angular. Basically, when you're describing grain shape, and in a rock, it'll be pretty homogeneous for the most part. But in it, like it is here, this is no exception to that. But in a lot of rocks, it's not. It depends on their origin. But we don't do that until we start interpreting. We're just looking to see what this rock is. So we have a bunch of angular particles in this. So you basically have very well-rounded or well-rounded. Sorry, it's humid out. It's hot. Even though it's clouds. Ugh. Anyway, so we have well-rounded, rounded. Rounded is typically, I don't want to say, like well-rounded would be what you see in an old creek. Those round rocks you pick up, it's rounded, it's well-rounded. Rounded's a little less of well-rounded. Then you have what we call subangular, which is you have some rounded angular edges, but overall it's kind of angular, and these are angular. All right, there's no doubt about it. This is all the grains, regardless of size, and it can change based on size, are angular. Usually, smaller grains will be more rounded than coarser grains. Usually. This is an exception to that. Why? Well, we're not going to make any interpretations yet. We'll come back to it, okay? So we notice we have grains here that are angular. Now, what's their size? Well, geologists use something called the phi scale, or the Wentworth scale, which is based off of phi scale, which is a logarithmic scale with even intervals, and it just so happens very fine sand, that bottom between very fine sand and coarse silt, is set right at about the smallest your eye can discern in a single particle. Okay, what is it? It's 0.065 millimeters, something like that. I forget. And sand, the coarsest sand is 2 millimeters. So when we look at this, we can tell we have no silt and clay in this for all practical intents and purposes. Okay, it's all sand and coarser. All right, now these bigger ones here, like this, like these two, these lighter ones, I'm picking on these because they're easily discernible. These are granules. In USCS, the soil classification that engineers use, this would be called coarse sand, but it's not. It's granular. And even though this rock, and this is one of those things that annoys me, you start to see everything in this is angular. Everything. From the smallest particle, which appears to be a medium to coarse sand. Nothing smaller than medium sand in this. Okay? All the way up to your granules, and in some cases, I saw a pebble. Where's the bloody, oh yeah, here. This is a pebble. You see this guy? Even though he's the same color, he's a pebble. All right? So, but that makes up maybe 1% of the rock. Most of this is medium sand to granular in size overall. But the granules are concentrated just in this bottom bed here. Okay, remember we have these laminations, we have this thicker bed, and below these laminations we basically have a thick bed as well. And this is jumbled up, and you do have some sub-angular, but most of these are angular. Okay, so this is a bed in and of its, where is the bottom of it? Sorry, in and of itself, right there, that's a bed. Okay, there's no internal structure, it's all haphazardly put in there. They're not even oriented very well. They do show preferred orientation of being level, because remember, this is the top. All right, so the granules and the fine pebbles are basically, oh, we have a big pebble right here too. All right, see it? So you got to look too and make sure that just because your rock's pretty much one color, this isn't, but close enough, doesn't mean you don't have other things in it. You see the pebble here? It's a big one, but like I said, this makes up 1, maybe 2% of the rock. Most of this rock is medium sand and granules. Most of the granules are in this bed here. Above that, it's mostly medium and coarse angular particles. Now, we're done talking about particle size, and I don't want this to go on any longer, but in the next video, we're going to talk about what this is.